Assalamu alaikum, dear student. Today I'm going to solve you AS level paper, that is 970122 theory paper, May-June 2020. Okay, so I'm going to solve this one. So the question 1 is related to the mass spectroscopy or mass spectrometry, you can say, and the graph is related to जो हमने क्या पढ़ा था atomic structure का part. You can say that this is the part of atomic structure, या फिर आप क्या कह सकते हैं, it is the part of moles or stoichiometry. In this question, examiner says gallium is an element in group 13. Group 13 mean group 3. ठीक है, so basically 13 हम बोलें या 3 बोलें तो is the same, mean it is the same group in which aluminium is present. A sample of gallium is analyzed using a mass spectrometer. The mass spectrum produces is shown. You can see this. So these are the relative heights indicating the relative abundance of the different isotopes. और ये जो specific graph है, this indicates that the gallium has two basic isotopes. One has the atomic mass of 69 and the other one has the atomic mass of 71. And also the relative abundance indicated that 69 atomic mass gallium isotope is in more percentage, so it is naturally in more abundance. So the demand of the question is, explain what is meant by the term relative atomic mass. So we can say that it is the average weighted mass of all the naturally occurring atoms of an element or isotope of an element as compared to 1/12 of carbon 12. Okay, so I'm going to write it like what you have to write. You can say it is the average weighted mass of all the naturally occurring isotopes of an element as compared to 1/12 of carbon 12. So this is the right answer and you can get easily the 2 marks. So we have to proceed, and in this part examiner says calculate the relative atomic mass of gallium in this sample. Give your answer to 4 significant figures, and the instruction is show your working. So you must have to show your working. So we have the basic formula for measuring the relative relative atomic mass. This is AR indicating the relative atomic mass, that is equal to the percentage abundance. We can say percentage abundance times isotopic mass plus percentage abundance times isotopic mass. And we have to repeat if we have more isotopes. We have to repeat this one if we have more, and then we have to divide it by the total abundance. Okay, so now we have to substitute the value using the graph. So in this graph you can see that one is the isotopic abundance is 60.11, so I have to replace 60.11 times the isotopic mass of this isotope is 69. So it is 69 plus, then the percentage abundance is 39.89, 39.89 times the isotopic mass is 71. So this is 71. You have to divide it by the total abundance, which is 60.11 plus 39.89. Okay, now you have to calculate mathematically. So you will get the answer 69.80. 69.80. Okay, so this is the right answer for part B. So proceeding towards the part C, and in this C part you can see here, complete the table which describes a gaseous atom of gallium. So gaseous, we can say isotope is gallium and the isotopic mass is 71. Nucleon number, so remember this is the mass, this is the atomic mass, or sometime it is called as the nucleon number. So we have to fill it by writing 71. So the right filling will be, this value will be 71. Next, total number of electrons in the lowest energy level. So you have to remember each and every element has the lowest energy level, that is 1s. So the electrons are filled in the lowest energy level, which is 1s. Then type of the orbital which contains the electron in the highest energy level. So we can say that as the gallium is in group 13 and group 13 is the p block, so we can say the last electrons are filled to the highest energy level, which is p. Or even we can say as the gallium is in the fourth period, or agar aap kya kare, you can check it from the periodic table, from the data booklet. So but the type of the orbital is p. Okay, so which type of, so we are mentioning the type, not exactly the position, which number or which principal quantum number it is. You just have to mention this is p. Okay, so now this part is complete. Hopefully you understand. Next part, this is the D part of the same question. When gallium is heated in excess chlorine, gallium trichloride GaCl3 is made. Draw the shape of the gallium trichloride molecule and suggest the gallium to gallium chlorine bond angle. Shape of the molecule. As it is clearly mentioned, the gallium is in the group 3 or group 13, so it has the similar behavior like aluminium. Like we can say aluminium chloride. So simply we can say gallium is bonded with 3 of the chlorine like this. Or okay, Cl and Cl. So this will be the simply, and what shape is this? We can say this is trigonal planar, as there is no lone pair on the central atom and the central atom has 3 bond pairs. So whenever there are 3 bond pairs of electrons and no lone pair on central atom, so we can say this is trigonal planar. And also remember the bond angle for the trigonal planar is 120 degree. So the bond angle for trigonal planar is 120 degree. So you have to remember it. And hopefully you will get successfully the 2 marks. In E part of the same question, gallium oxide Ga2O3 and aluminium oxide react in the same way with HCl and with NaOH. So you have to remember aluminium oxide is an amphoteric oxide. So as it is clearly mentioned, aluminium oxide and the gallium oxide has the same, or they react with the same way, so it definitely indicates the gallium oxide is amphoteric too. So now suggest the equation for the reaction between gallium oxide and hydrochloric acid. So we have to write the equation like this. Here this is Ga2O3 plus HCl, so it produces GaCl3 plus H2O. Like the neutralization reaction takes place, this behaves like a base and this is an acid, so we have to balance it. For balancing we need 2 gallium atoms. For that we have to place 2 over here with the gallium chloride, and as a result we got 6 chlorine, so we have to place 6 with the HCl. As a result we got 6 hydrogen atoms. To balance the hydrogen atom we have to place 3 with the water. So as a result the equation is balanced. Now in the next part, second part of the E subpart, suggest an equation for the reaction between gallium oxide and sodium hydroxide. So what we have to do here, again try to remember the reaction of the aluminium oxide with sodium hydroxide, and you just have to replace the aluminium with gallium. That's it, nothing to worry about. So the product we get, it is sodium NaGaO2 plus H2O. Now to balance this equation, as we have 2 gallium, so we have to place 2 over here. As a result we got 2 sodium. To balance this out we have to place 2 with the sodium, and the rest of the equation is balanced. Hopefully you understand. And you have to keep the way which aluminium oxide is reacting with the NaOH. Here we just replace the aluminium with gallium. That's it. So the question 1 is complete. Now proceeding towards question number 2 on page 4 of the same paper. Nitric acid or nitric acid can be made in a 3-stage process, and here are the stages mentioned. Some conditions are also there. In stage 2, nitrogen monoxide that produced in the stage 1 is further oxidized in presence of oxygen into nitrogen dioxide. And remember, nitrogen dioxide is a brown gas, and the equation in a forward way is exothermic. In third stage, the nitrogen dioxide produced in the previous stage is mixed with water to get the nitric acid, including the nitrogen monoxide. So here write an equation to show the reaction occurring in stage 1. So here all the conditions are mentioned. Examiner said that ammonia is reacting with oxygen, so we have to say that ammonia has the formula NH3 is reacting with oxygen in the presence of a catalyst. Okay, like we may say we may use platinum, palladium or rhodium, but here the platinum is also mentioned from the examiner, so we no need to write that, and the other conditions as well. Just to write the equation, we get nitrogen monoxide and steam as the temperature is too high. So to balance this out, as we have here 3 hydrogens and we have 2, so we have to multiply it with 2 and with water with 3. So as a result nitrogen got balanced. To balance the nitrogen we have to place 2 here, and now to balance the oxygen we have 2 plus 5, 3. So we have total 5 oxygen. To balance the oxygen we have to place 5 by 2. And remember, the balancing is allowed in fractions, not in decimals. So try not to balance the equation in decimals. Try to balance the equation with fractions. Okay, in the next B part of the same question, draw a dot and cross diagram to show the arrangement of outer electrons in a molecule of ammonia. So we have to remember nitrogen is in the 5th group of periodic table, has 5 electrons in its last shell, 1, 2, 3, and the 2 electrons are here. And as it is combining with the hydrogen, and hydrogen has only 1 electron and need 1 more electron, so the dot and cross structure will be completed like this. Okay, so this is the dot and cross structure of the ammonia. Got it? So total 1 mark, so no need to worry, just to draw it clearly. Then in C1, in the boxes, give the oxidation number of nitrogen in the nitrogen containing species for the reaction in stage 3. So the reaction in stage 3 is clearly mentioned again. We have to work out for the oxidation states. So here I'm going to write, like we can say, the nitrogen dioxide. Here you have to remember oxygen has the oxidation state of -2, and as we have 2 nitro oxygen atoms, so we can say here generally we have to apply the common rule of calculating the oxidation state. As this is a neutral compound, so sum of all the oxidation states of atoms present in this compound must be 0. So we have to break it down. We have 1 nitrogen which we have to find. We have 2 oxygen in this formula, and each oxygen has the oxidation state of -2 and is 0. So to solve this equation, we got the +4. So the oxidation state of nitrogen in nitrogen dioxide is +4. Then in HNO3, and also remember the balancing numbers are not included for the oxidation states or in calculation of the oxidation states. So HNO3 again a neutral molecule, so sum of all the oxidation states must be 0. Here we have 1 hydrogen which we have to put as +1, as in all compounds hydrogen has the oxidation state of +1 except in hydrogen that is bonded with metals. Plus we have to find for the nitrogen, and we have 3 oxygen atoms. Each oxygen has the oxidation state of -2, so total is 0 again. To solve this situation, we get the value of n as, this is 3 2s are 6, -6. When it goes to this end, it will become, or when it added to +1, we got -5, and finally we get +5. So the oxidation state of nitrogen in nitric acid is +5. Now we're left with only NO. It's very simple, as this is again a neutral molecule, so the oxidation state of all the atoms present in this molecule must be 0. And as we have to find for the nitrogen, plus we know the oxidation state of 1 oxygen which is -2, so when it goes to the other end of the equation it becomes positive, and the final answer for is +2. So simply we can say that the oxidation state of NO2, nitrogen in NO2, is +4. The oxidation state of nitrogen in nitric acid is +5, and the oxidation state of nitrogen in nitrogen monoxide is +2. So simply we can say that at first it increases the oxidation state and then it decreases. So we know that all those reactions in which the same species is getting oxidized and getting reduced, those reactions are considered as disproportionation reaction. So remember that this is an example of disproportionation reaction, the reaction in which both oxidation and reduction takes place of the same atom or the same species. When same species get oxidized and get reduced in the same equation, then that equation will be considered as disproportionation reaction. Okay, so the next part in 2, explain why the reaction in stage 3 is described as disproportionation reaction. So as I already mentioned, the equation in which the same species get oxidized and get reduced by losing electron and by gaining electron, that is why it is called as disproportionation. So you have to say that in nitrogen dioxide, in conversion of nitric acid, losing one more electron, whereas the nitrogen dioxide in conversion to nitrogen monoxide, gaining two more electrons. That is why we can say the oxidation state is decreasing. So what you have to write, we can say nitrogen dioxide in conversion to nitric acid, losing one more electron. That is why its oxidation state increases from +4 to +5, whereas the oxidation state of nitrogen dioxide to nitrogen monoxide is decreased from +4 to +2, indicating that 2 electrons are gained. Hopefully you understand. So moving towards the next part at page 5, D part of the same question, question number 2 of the same paper, the release of nitrogen monoxide into atmosphere cause atmospheric pollution. State and explain the effect of nitrogen monoxide gas in contact with moist air. So we have to say that instructions are clear that state and explain the effect of nitrogen monoxide gas, okay, when it contact with the moist air. So it cause acid rain. What we have to state? It form acid and causes acid rain. What other effects are? That damages the plants or the crops by washing away the useful nutrients, or you can say that it may cause irritation to the skin, it may cause damage to the stonework, the buildings made up of limestone, or you can say that these may damage or harmful for the marine life or the aquatic life, as the water get little bit acidic when the acid rain drops or the acidic water drops into those water reservoirs. So simply you have to say it causes acid rain. Okay, here I can help you by just mentioning how. Remember, nitrogen monoxide, okay, in the atmosphere, can nitrogen monoxide get oxidized in presence of further oxygen in the atmosphere into nitrogen dioxide? That nitrogen dioxide easily oxidizes the sulfur dioxide into sulfur trioxide and nitrogen monoxide back form. So that is why we can say it is behaving like a catalyst as it is recovered. And then you can say that the sulfur trioxide produced here mix with the moisture and causes acid rain, H2SO4. In other way, directly the nitrogen dioxide produced in presence of further oxygen mix up with the moisture and produces nitric acid, which again causes acid rain. Got it? So hopefully you understand. Now in E part, the nitric acid made in stage 3 can then be reacted with ammonia to form ammonium nitrate. Remember, ammonium nitrate is a nitrogenous fertilizer. Then said that calculate the volume of nitrogen dioxide measured at room temperature and pressure required to make 40 tons of ammonium nitrate. and have to remember 1 ton equals to 1000 kg, and also remember 1 kg equals to 1000 grams. So how to calculate these? Here I'm trying to solve this question. For what you have to do, just try to understand the nitrogen dioxide is involved in making nitric acid. Nitrogen dioxide is involved in making nitric acid. So the ratio is NO2 to HNO3 is 2 and 3. The ratio is 3:2. But as we don't have any data related to the nitric acid, so we have to check that nitric acid is involved in the formation of what? Ammonium nitrate here. So make 40 tons of ammonium nitrate. We have to find the amount of nitrogen dioxide, but we got the 40 tons of ammonium nitrate. So the another ratio we have to make is between the nitric acid and ammonium nitrate. Got it? So the other ratio is nitric acid and ammonium nitrate. From the equation, it is of 1:1. When we have 1 mole of this one, it also reacting with the ratio or producing with the ratio of 1. So now we have to find the moles of ammonium nitrate. Here we have to find what? Moles of ammonium nitrate. How? By dividing the given mass with the MR or the formula mass. You can say the formula mass. So the given mass is 40, but remember tons. So to convert it into the tons, we have to multiply it by 10,000 and then 1,000. Okay? Sorry, not 10,000, 1,000 and then 1,000. As the conversion says 1 ton is equal to 1000 kg. 1000, then to convert it into grams, we have to further multiply it by 1000. Divided by the MR of the ammonium nitrate. Remember, here we have 2 nitrogen atoms. So 2 times the atomic mass of nitrogen is 14. Plus, we have 4 hydrogen atoms and the atomic mass of hydrogen is 1. Plus, we have 3 oxygen atoms and the AR of oxygen atom is 16. Now you have to do the calculations. So when you do the calculation, you get the answer 500 and then 000. So this is the right answer for this one. So now as the mole ratio is same, we can say that the same moles of the nitric acid we get. This is okay, the same mole as the ratio is same. Now we have to convert this one over here. Okay, so the moles of the nitric acid, here we have 5. So what should be the value of this one? So this will be the x. Now by cross multiplying, we get that x will be equals to 3 times 500 000 then whole divided by 2. So we have to do the calculations again. So as a result, we will get the answer 750 000 moles. And finally, as we need the volume of the gas, so you know that volume of gas is equal to moles times 24 dm cube. So we just have to multiply the obtaining answer, that was 75000 times 24. When you multiply it with this one, you will get the answer, that is 18000 and then 000. So dm cube. So this is the final answer. I tried my best to solve the question in a very simple way if you found this one difficult, you can adopt any other method, but use proper ratios, proper values, you will get the same answer as well. Okay, there are several other methods too, but those are little bit tricky or little bit complex, so we have to use a very simple way like this. If you try to understand, you will get and you will understand it very easily. Okay, now here state one use of ammonium nitrate. As I already mentioned that the ammonium nitrate is a fertilizer, so you can say that fertilizer, so it can be used as fertilizer. So here we completed this question as well, and proceeding towards question number 3. The question number 3 is related to, I think, is organic. So here what it is mentioned, question 3, sucrose C12H22O11 react with water to form glucose and fructose in reaction A. And it is clearly mentioned that from this one is the molecular form and this one is the displayed form. The only difference, as we have 12 carbon, and if you count these, there are 6 carbon and the 6 carbon in both molecules. The hydrogen and the oxygen are also same, so we simply say that these two molecules are the isomers of each other, as their molecular formula is same, but the arrangement of the atoms is only difference. So we can say that suggest a name of this type of the reaction. So remember that whenever we are adding water to any complex molecule, and by the addition of water any complex molecule is broken down into 2 or more parts, then that will be considered as what? Hydrolysis. We can say that this is the example of hydrolysis. Addition of water that causing breakdown to the complex molecule is called as what? We can say this is the hydrolysis. Now in B part, explain in detail why glucose and fructose are pair of structural isomers. As I already mentioned, from this part we can say that both fructose and glucose have same molecular formula, but the arrangement of the atoms is different. And then instruction was also there, your answer should refer specifically to these two molecules. So clearly I mentioned in my answer that both glucose and fructose have same molecular formula, and even you can mention the molecular formula too by counting the number of carbon atoms, hydrogen atoms and oxygen atoms. So we can say that both fructose and glucose have same molecular formula, but the arrangement of the atom is different. That is why both are the pair of structural isomers. Then proceeding in C part, reaction A occurs faster in the presence of an enzyme. This is reaction B. The activation energy for the reaction B is plus 29 kilojoule per mole. Predict a value for the activation energy of reaction A. So remember that, as we know, catalyst increases the speed of reaction by providing an alternative route, and by providing the alternative route the activation energy decreases. So that is why you just have to mention any value that is lower than this one, as this 29 is the activation energy of reaction, the activation energy of B. We must have to write the value higher than this one, as by using the catalyst the activation energy decreases. As the reaction A is proceeding without the catalyst, we can say that its activation energy must be higher than this value. Okay, so you have to write any value, even you write 30, this is fine too. So the value that it must be higher than 29. Then next part, the enthalpy change of reaction A is minus 14 kilojoule per mole. predict a value for the enthalpy change for the reaction B. We can say that the enthalpy change remains unchanged, as the catalyst only affect the activation energy by providing alternative route, but it doesn't affect the enthalpy change. So the enthalpy change remains the same, so we have to write the answer minus 14. Okay, we have to write the answer the same value, that is minus 14. Okay beta, now proceeding towards the next part. This is the seventh question of the same paper on seventh page of the same paper, and the third part of the question number 3, subpart C. Here examiner says sketch a labeled energy level diagram for the reaction B. Remember, reaction B was catalyzed. Use relevant values from C1 and C2. There it is also mentioned the enthalpy change and the activation energy, the value of activation energy. So what we have to say here, I'm going to draw it like we have the x-axis and y-axis. On the x-axis we have to label it as reaction pathway or the progress of the reaction, and on the y-axis we have to mention energy in kilojoule per mole. And as the reaction is exothermic, the value on the back page indicates that it is of negative. The enthalpy change is in negative, indicating the reaction is an exothermic. So for exothermic we have to mention that the reactants are higher than the products. So you have to show the products little lower. Here these are the reactants and these are the products. From the level of reactants towards the peak, this is the activation energy. We have to label it as EA. And from the level of reactant to the level of product, this is enthalpy change, delta H. And you may write the values, this is minus 14. And as it is for the reaction B, we know the activation energy, that is plus 29. Okay, so this is the energy profile diagram for reaction, that is B. Now in D part, 1 grams of sucrose has the formula C12H2211 is completely combusted. The heat energy produced is used to increase the temperature of 250 gram of water inside a calorimeter from 25 degrees Celsius to 40.7 degrees Celsius. These data can be used to calculate the enthalpy change of the combustion of sucrose. So I here advise you to use Q equals to minus MC delta T formula. But as the demand for the next part is explain what is meant by the term enthalpy change of combustion of sucrose. So you must have to explain or define in the combustion energy by using the word sucrose in your description. So you have to say that the amount of energy or the enthalpy change when 1 mole of sucrose is combust in excess supply of air. Here I have to write it too for your ease. We have to say that enthalpy change when 1 mole of sucrose is combust in excess supply of air, or we can say oxygen, under standard conditions. Under standard, so this is compulsory to write this one, as this is the standard enthalpy change of combustion. So this is the standard or the term enthalpy change. Acha, as there is no standard, so we may ignore the words that is under standard conditions. In the second part, use the data booklet to calculate the enthalpy change in kilojoule per mole for the combustion of sucrose. Assume that all the heat energy produced is transferred to the water. So, as I advised, we must have to use the formula Q equals to minus mc delta T. Q is the amount of heat energy. Q is the amount of heat energy, and minus m. M is the mass of solution times we can say C is the specific heat capacity of water times delta T is the change in temperature. So we have to displace or substitute the values. Here in this situation, 1 gram of sucrose is burned completely, 250 gram of water. So the mass of water is 250 times the C is the specific heat capacity, and its value is 4.2 or 4.18 according to the data booklet. So you must have to follow your data booklet given. So you must have to follow the data booklet given. Next thing is to put the value of delta T. This is the final minus initial temperature, which is 40.7 minus 25.0. When you calculate this one, you will get the answer. So we have to use the calculator. Just a minute, I'm going to solve this one. I have to open the calculator, and in the calculator, so we have to put 40.7 minus 25. So it is 15.7 times 4.2 times 250. So the final answer is minus 16485 joules. And to convert this one into kilojoules, we have to divide it by 1000. As a result, we will get minus 16.485 kilojoule. Okay, as we need to find the enthalpy change, so for that we have to make a ratio. We can say that when 1 gram of sucrose is burned, so 1 gram of sucrose is involved in releasing 16.485 kilojoule energy. As I am using the word release, that is why I'm not mentioning the sign negative. Okay, then if what we have to say, what is the molar mass? As we have to find the energy released by 1 mole, so we must have to find the molar mass, that is the MR of sucrose. MR of C12 H22O11. So how? By multiplying the 12 number of carbon atom, and the AR of carbon is 12, plus 22 the number of hydrogen, and the AR of hydrogen is 1, plus 11 is the number of oxygen, and the AR of oxygen is 16. So we have to find the molecular mass of this compound. So this will be 12 times 12 plus 22 plus 11, okay, sorry, 11 times 16, 176, 12 times 12, it is 144, then 144, 11 times 16, 176 plus 144 plus 22. So this is 342. Okay, so now we have to say if the value or the mass used, molar mass, that is 342, what should be the enthalpy change? What should be the enthalpy change? So we have to multiply this, cross multiply. As a result, we get multiply by the value multiply by 16.485. So the answer is 682.67. As it is the exothermic reaction, so we have to put the value minus, and the unit is kilojoule per mole. Hopefully you understand how to solve this part. Okay, so you get the answer 5637.87. Your answer may vary with the examiner mark scheme depending upon the value we used here. Okay, so if you use 4.18 or according to the data booklet that is given in that relevant paper, you may get slightly different values. Okay, but the procedure remains the same. So try to understand the procedure. Values may vary depending upon the use of the data booklet, which type of the data booklet you have by that time. As this time I have the data booklet which is showing the specific heat capacity, that is 4.2. okay, so now this question is complete. Hopefully you understand. Okay, so moving on to page 8 of the same paper, and question 4. An unlabeled bottle contains a straight chain halogenoalkane Q. The molecular formula of Q is C5H11X, where X is a halogen. It may be bromine, chlorine, or iodine. A test is carried out to identify the halogen present in Q. A sample of Q is added to sodium hydroxide aqueous and warmed. Dilute nitric acid is then added, followed by a few drops of aqueous silver nitrate. A cream precipitate is observed. Okay, so cream precipitate is observed. So remember, the cream precipitate indicates the formation of bromide ions or silver bromide. Okay, so suggest the identity of X, we can say it is bromine. Write an ionic equation to describe the formation of the cream precipitate. For this one, we have to write the ionic equation contains the silver ion in aqueous form, the bromide ions in aqueous form too, when these two combine producing AgBr solid. So this is the ionic equation for the formation of cream precipitate, cream colored precipitate. Then describe a further test which would confirm the identity of X. So we can say that we have to add aqueous ammonia. Here it is mentioned that followed by a few drops of silver nitrate, and there is no aqueous ammonia. Okay, so you have to mention that add aqueous ammonia, excess aqueous ammonia. So we can say that the precipitate partially dissolves. And if you mention that add concentrated aqueous ammonia, then you have to say that the cream colored precipitate completely dissolved. So you have to clearly mention if the solution of the aqueous ammonia is dilute, then cream colored precipitate partially dissolves, and if the aqueous ammonia is concentrated, then the cream colored precipitate completely dissolves. Then the reaction of Q with NaOH tends to proceed via an SN2 mechanism. So it clearly indicates that our halogenoalkane is primary or secondary, as the primary and secondary halogenoalkanes proceed through SN2 mechanism, the nucleophilic substitution bimolecular mechanism. Okay, so suggest the structural formula of the straight chain. So this clearly indicates that we have the 5-membered halogenoalkane 1, 2, 3, 4, 5, in which the halogen, that is bromine, connected to the position which makes it a secondary halogenoalkane. So here we have two, you have to mention hydrogen here we have hydrogen, and is the same way here. So we can write, or we can convert it according to the situation. What is demand? The structural formula. So as this is the displayed formula, you have to convert it into the structural format. This is CH3, CH2, CH2, CH, Br, CH3. As this bromine is connected to the carbon, which is further bonded to two carbons and one hydrogen, that is why it is secondary halogenoalkane. Okay. And even you can say this is primary halogenoalkane. As I mentioned that the halogenoalkane that is proceeding via SN1 mechanism may be secondary halogenoalkane or maybe primary halogenoalkane, but definitely not the tertiary one. You have to remember, it will not be tertiary, but it can be primary or it can be secondary. Then explain why the reaction tends to proceed via an SN2 mechanism rather than an SN1 mechanism. So you have to say that in the formation of, or the the tertiary halogenoalkanes involve in formation of more stable carbocation, whereas the primary and secondary halogenoalkanes are involved in the formation of less stable carbocation. That is why the given halogenoalkane will proceed through SN2 rather than SN1. Hopefully you understand. I again repeating, the tertiary halogenoalkane proceed and involve in the formation of more stable carbocation, that is tertiary carbocation, but the primary and secondary primary halogenoalkanes are involved in the formation of primary carbocation, which is far less stable. Okay, so proceeding the page 9, same question 4, part C. Two different halogenoalkanes P and R, both with the molecular formula C4H9Cl, are separately dissolved in ethanol and heated under reflux with sodium hydroxide. So it is clearly indicating the reaction about the elimination reaction. So it is clearly mentioned about the elimination reaction. Okay, so I'm talking about the elimination reaction. When any halogenoalkane is treated or reacted with the sodium hydroxide that is dissolved in alcohol or ethanol, that indicates and is heated under reflux, so it is indicating about the elimination reaction. This is about the elimination reaction. So you can revise or you can understand this by reading or revising your chapter of halogenoalkanes. The major organic product of each of these reactions is methylpropene. Name the type of the reaction occurring. So as I already mentioned, this is elimination reaction. Write an equation using molecular formulae to represent the reaction occurring. So here the one molecular formula is written, and elimination indicates that to one carbon atom chlorine is eliminated, and to the adjacent carbon atom hydrogen is eliminated. So one hydrogen and one chlorine eliminated, remaining will be C4H8. So we have to write it in the molecular form. We have C4H9 and Cl. When we heated it with NaOH alcoholic and heating under reflux, HUR mean heating under reflux, we get C4H8 plus HCl. Okay, so HCl is eliminated. That is why this reaction is called as elimination reaction. Then say draw the skeletal formula of methyl propene. So we have to draw the skeletal formula of methyl propene. So double bond we have to show, and methyl propene total carbon atoms here. So this is methyl propene. So this is carbon 1, this is carbon 2, this is carbon 3. So this is 2 methyl propene. This is 2 methyl propene. Got it? So give the name of P and R. So you have to say that the two different halogen alkanes P and R both with the molecular formula. So we have to say, or we have to then give the name of P and R only. So for this one we can say the both halogen alkanes are P and R will be, like here we have CH3, then CH, here we have the Cl, and then we have CH3, and here we have we can say CH3. So not to write here. So this is tertiary halogen alkane. So whenever we have to remove the chlorine here and the adjacent carbon hydrogen is removed from this carbon, so we will get 2 methyl propene. So this may be P. So the name will be 2 methyl 2 chloropropane. 2 methyl 2 chloro, or sorry, you have to follow the alphabetical order. 2 chloro 2 methyl propane. Okay, so this may be P or Q, and then we have to write the name of the R, and the other one will maybe, like I have to draw it, if the structure is CH3 CH CH3 and then CH2Cl. So it will be, when the chlorine is removed from this carbon, the adjacent carbon hydrogen is only this one. So the double bond form over here, and we, as a result, we will get, as a result of elimination, we get 2 methyl propene. Okay, so the name of this compound will be 1 chloro 2 methyl propane. Hopefully you understand. So now this question is also completed, and now proceeding towards hopefully the last question, the last part. This is the 5th question of the paper and is the last question. So the reaction sequence shows how ethene C2H4 can be converted into other organic molecules. Here is the reaction mechanism, reaction sequence, which is called as synthetic route of formation of the W. This is C2H4 ethene going and producing ethanol. So here we can say the hydration takes place, or we can say this is the nucleophilic addition is occurring with the steam in presence of some special conditions, like we can say 300 degrees Celsius temperature, 65 atmospheric pressure, and phosphoric acid as a catalyst. So as a result, this ethene converted into ethanol. Then ethanol in reaction 2 is converted into aldehyde. So the mild oxidation, like in the presence of acidified potassium dichromate, the alcohol, the primary alcohol, get oxidized into the aldehyde. Then aldehyde in reaction 3 going through and formation of the nitrile is taking place. So we can say here the nucleophilic addition is taking place, and this aldehyde is reacting with HCN, hydrogen cyanide, in presence of KCN, heat under reflux. And then the nitrile is obvious, when is hydrolyzed in presence of the acid, we get the carboxylic acid. Okay, so this nitrile is hydrolyzed, is broken down into the carboxylic acid. Now in reaction 5, the OH is replaced with the chlorine. So this is done only by using PCl5 at room temperature or SOCl2 at room temperature as well. So again, substitution reaction is taking place in the reaction 5. And in the reaction 6, the Cl is replaced with NH2. So this is the reaction of halogenoalkane again, as we discussed in the previous part. So again, nucleophilic substitution reaction takes place when we are reacting with ammonia alcoholic heat under reflux. This chlorine as a nucleophile substituted with amine nucleophile. So nucleophilic substitution is occurring over here. So what are the demands from the examiner? Complete the table to give the name of the reaction mechanism of reaction 1 to 6. So we have to write the name, as I already claim or clearly mentioned what type of the reactions are occurring here. So you have to say reaction mechanism in reaction 1 is electrophilic addition. So this is electrophilic addition. Got it? Then reaction 2 is not here, so we have to name the reaction mechanism of the 6. 6 is, I have already mentioned, this is nucleophilic substitution. 6 is what? Nucleophilic substitution. And for the name of the reagent and condition in reaction 1, we have to say we have to add steam is the reagent in presence of phosphoric acid, which act as a catalyst, and we have to provide 300 degrees Celsius temperature and 65 atmospheric pressure. For reaction 2, here it is what oxidation is taking place, so we have to write acidified potassium dichromate is the what reagent. Then in the sixth part, the reaction 6 here, the reaction 6, we need ammonia alcoholic heat under reflux. Ammonia alcoholic heat under reflux. Hopefully you understand. Then in the next part, B is the last part of the same paper, 11th page. In reaction 3, the organic molecule react with HCN and a KCN. So KCN is a catalyst and HCN is the reagent. Complete the diagram to show. So here we have to complete the diagram as I have to draw over here. So this is C double bond O, here we have H and here we have CH3. And this is the nucleophile over here, carbon having a negative charge. So you have to show a lone pair, and then before attacking you have to show partial negative charge over the oxygen of the carbonyl and partial positive charge on the carbon of the carbonyl. Then by showing the curly arrow, by using the curly arrow, point the electron pair attacking over the carbon of the carbonyl group, and as a result this bond is withdrawn towards the oxygen here. As a result, what happens? We will say that we have to follow the same way oxygen is producing over here. So this oxygen broken down, taking away its electron, as a result it will have one extra electronic pair and acquire a negative charge. And here we have hydrogen already, here we have CH3 already. The Cn is added to this position. Cn is added to this position. You may write like this, Cn only or C triple bond N. It's your choice. Then further it is mentioned over here H that is bonded with C that has a triple bond with N. So you have to show the lone pair. Prior to this one you have to mention the partial positive charge over here, the partial negative charge over here. This electronic pair, curly arrow, using curly arrow you have to attack it over the hydrogen ion, and the carbon atom will pull out its electron pair over here. And as a result the Cn ion, cyanide ion generated again, indicating, so what we get as a result, here we have CH3, here we have H, here we have O, that due to the connection with this one making OH bond, and here we have Cn. And the C triple bond N with a negative charge and a lone pair of electron regenerated. So as CN is initially present and is recovering by the end, so it is a catalyst. It is acting as a catalyst. So you have to remember this is acting as a catalyst. So name the functional group present in the product of reaction 3. So product of reaction 3, where is the reaction 3? Here, the product of reaction 3 is this one, and this is nitrile. Okay? And here we have the hydroxyl group as well. So hydroxynitrile, so we have one hydroxyl group and hydroxyl functional group, and the other one is nitrile functional group. Draw the structure of the organic molecule W formed in reaction 4. So we mentioned here, we got this one, and when this one is hydrolyzed in presence of acid, okay, water is being added in presence of the acid, heat under reflux. As a result, this compound hydrolyzed, producing CH3 bond H bond OH, but this CN is hydrolyzed into CO2H, producing ammonium ion. But as we have to mention only the organic product, so this is the organic product. This one is the organic product. Okay, so he said the structure. So this is the structure of the organic product W. Got it? Hopefully you understand. If you have any query related to this paper, so you may ask in comments. I will definitely answer, inshallah. Okay, so all of you, beta,